Alright, we are on question 8 of the November 2018 South African Syllabus CAPS exam for Matric Mathematics paper 1. Question 8 is differentiation, right? Everything looks like differentiation. Let's see what we have here. So 8.1, determine f prime of x from first principles if we get given what f of x is. Okay, so let's just first, before we get to that, let's go with what first principles is. Where does it come from? Okay, so for that, I'm just going to draw a quick grid and draw a bit of a curve. Okay, so let's say we've got that curve, and then I'm going to get rid of some of it. Okay, what's the eraser? Okay, so let's say I just want part of this curve. Okay, now let's select that curve, and I'm just going to drag it onto here. So let's say we've got that curve. Now we want to do something with it. We want to find the gradient of this curve, right? So how do we find a gradient? Well, we know from straight lines we can find a gradient by just saying change in y over change in x. So let's say we want to find the gradient at this point here. Right, so we know we can approximate the gradient by taking a straight line. So if we take another point somewhere on this grid, and we just connect those two, right? We just connect these two straight lines, or these 2 points with a straight line, then we can approximate the gradient over here by taking a gradient of the straight line. Right, now, that gradient, how will we do that? Let's do black. Okay, so this value here is x. Right, and then this value here is f of x. Now, let's say this point was a distance of h away from x. So what will this x value be then? X plus h, right? And then this output value, the y value, will be f of x plus h. Right, so approximating the gradient by using the straight line gradient, we would say then it's change in y divided by change in x, right? So the top would be f of x plus h minus f of x. So the change in the y values divided by the change in the x values. So x plus h minus x. Right, but x and x cancel out. So we just have h left at the bottom. So that's our formula for the gradient. But now obviously we can see that's not correct, because this line's gradient is not the same as what the gradient would be right over here. So what we then do is we want to say, well, if we get this point closer and closer, right? So if this point is here, then that line would be a bit better. If it's here, it would be even better. And if it's right next to it, zero distance between these 2 points, then obviously that would be the perfect gradient. That straight line gradient would be the same as the curve's gradient at that point. So that's why we say we want to take the limit of this function as h becomes 0, as the gap between these two becomes really, really small. If it approaches 0, then that will give us the gradient at the point on the curve. Right, so this is the formula we need to use. This is just an explanation of where it comes from. All it is change in y over change in x as the distance between the 2 points become very small. Alright, I hope that helped clarify where this formula comes from to you guys. Okay, let's see. So let's use this to solve for that. Okay, so we want to find, so f of x, let's just write that down first. F of x is x squared minus 5. X squared minus 5. Now, we want to find the gradient of that curve. So that's going to be the limit as h approaches 0 of, like we said, f of x plus 5. So what is f of x plus 5? All we do is replace the x with x plus h, right? So instead of an x, we've got an x plus h. So x plus h squared minus 5 minus f of x, and f of x we know is x squared minus 5 all over h. Now the idea of when we're doing limits, we want to replace this value with this value. So we want to replace h with 0. But if we do that straight away, we're dividing by 0, which is impossible. That's the problem. It's undefined, right? That can give you anything. So we don't want to do that yet. First, we want to simplify this so we don't divide by 0 anymore. So we're going to keep going. And remember to keep on writing this limit thing here. Limit as h approaches 0. Okay, now we just multiply out, so x plus h squared is x squared plus plus 2xh plus h squared minus 5, and then multiply the minus in, so minus x squared minus minus 5 is plus 5 all over h. Okay, equals limit as h approaches 0. Now we see x squared minus x squared is nothing, right? Minus 5 plus 5 is nothing. So what we're left with is 2xh plus h squared over h. Okay, so now we're getting somewhere. So what do you think we can do next? Because we eventually want to make it so we don't divide by h anymore. Right, so yes, exactly. We can take out an h at the top as a common factor. And then we have 2x plus h inside the bracket over h. And now the beautiful thing about that, now the h's can cancel out. Great stuff. So now our next step, and we're getting very close to the answer now, limit as h approaches 0 of what's left? 2x plus h. 2x plus h. And now finally we can replace the h with a 0. So equals 2x plus 0. And now we don't write limit anymore because we've done the replacement, right? So it's not as h approaches 0 anymore. We've already made h 0. So that just gives us 2x. Just rewrite that to look like 2x at least. So 2x. So that is the gradient of this curve. Great. All right. That was 8.1. Now let's look at 8.2. So 8.2. Determine dy dx. So maybe just something else to notice. If we get this, that means differentiate. Dy dx, that means differentiate. That just says differentiate y with respect to x. This also means differentiate. So all these three things, they are exactly the same as each other. Doesn't matter which one you write, it is exactly the same thing. Okay, so dy dx if that. So it just says differentiate the following. So 8.2.1, we want to differentiate this. This is already in a nice form that we like. So what we want to do is we just want to differentiate each part separately. So the short method of differentiation is if we have ax to the power n, and we want to differentiate this. All we do is say n times in front, and then we subtract 1 from the exponent. Right, so that's all we'll do with each one separately. So if y equals 3x squared plus, or 3x cubed, sorry, 3x cubed, let me rewrite that. So 3x cubed plus 6x squared plus x minus 4. Then y prime, or dy dx, so let's write dy dx because that's what they wrote in the question. Then we just say 3 times in front, so 3 times 3 is 9x, and then 3 minus 1 is 2. Okay, same here. 2 times 6 is 12x, and then 2 minus 1 is 1. So that's it. Then plus, okay, so here we just have an x, so 1 times 1 is 1. X to the power 1 minus 1 is 0. But x to the power 0 is just 1, right? So we don't have to write that. So that's just 1. And then minus 4, there's no x's there, so that just falls away. So any constant just falls away. And the reason, if you have a graph and you have the line y equals negative 4, that's a flat line. What is the gradient of this line? Right, if it's the x-axis and that's the y-axis, what's the gradient of this line? 0, right? So what's the gradient of that? 0. So we don't need to add that. So constants fall away. All right, so that's done. That is dy dx for 8.2.1. Now let's do 8.2.2. Okay, yx minus y. Oh, this looks a little bit complicated. Let's see. And write down the equation first. So yx minus y equals 2x squared minus 2x. Okay, and obviously this is for x not equal to 1, because if x is 1, what happens then? Well, let's see what happens if we put x equal to 1. So let's just do that in rough work, just for interest sake. So if x is 1, then we've got y minus y equals 2 times 1 squared, so equals 0, right? So we get 0 equals 0. So that's the problem when x equals 1, we get 0 equals 0. That's not going to help us in life at all. At least it's true. Okay. So let's get back. Now, if we want to find dy dx, so we want to differentiate y with respect to x. Okay, so let's see, can we get y by itself? Now it looks like we probably can't because of this yx part here. So let's just check what happens if we try to get y by itself. Can we do that? Well, actually we can, because we can factor out a y, right? So if we factor out a y, what's left is x minus 1, then equals 2x squared minus 2x. Okay, now to get y by itself, we can divide both sides by x minus 1. So y equals 2x squared minus 2x over x minus 1. Alright, what can we do next? Well, we can factor out the top as well, right? We can take out a 2x as a common factor. And what's left? X minus 1. At the bottom we've got x minus 1. So we can just cancel those. So y equals 2x. So this is quite nice. So the tricky part of this question was just to simplify it out into y by itself, to make y the subject of a formula. Right, now differentiating this is really easy. So dy dx equals, so 1 times 2 is 2, x to the power 1 minus 1, 0. So we don't have to write the x to the power 0 because that's just 1. So the gradient is just 2. And that's it. Now there is also, you could also use implicit differentiation here, but I don't think we need to worry about that. I think this is sort of what they're looking for. I'll have a look at the memo. Actually, I think I might have the memo open somewhere. But I'll have a look at the memo and see what if they had anything else. I'll add an extra bit in later. But I believe this is what they want. Alright, so that is differentiation. So the basic idea, this is the basic idea of differentiation. It's just finding the gradient by taking a limit as the difference or the distance between 2 points become really, really small. Then we can find the tangent line, which is the same gradient. And this is sort of the short method. Again, if we have f of x, let's just write that down at the bottom here. If we start with some function and that function is in this form, then if we differentiate that function, we just say n multiplied in front, so n times a, x to the power 1 less. Right, so whenever you have any questions in differentiation, you want to rewrite the initial equation so you have something like this. Something times x to the power something else. Right? And you want to do this, if all the terms look like this, you can just differentiate all the terms using this method. Alright, so that's it for question 8, and I'll see you again for question 9.